The DynaMO project is presented by myself, Joachim, CEO of Adaptive Robotics, and Øystein, CTO of Adaptive Robotics. This use case is presented by Adaptive Robotics located in Oslo, Norway. Adaptive Robotics is a spin-off from SINTEF, the largest research institute in Scandinavia. Adaptive Robotics is the only partner in the DynaMO project. However, the project had 3 important collaborators which made the demonstration possible. KUKA R&D Lab in Augsburg, SICK, which is a German global supplier of vision-enabled robot cells, and Civid, global supplier of 3D cameras for robotics. The main purpose of this demonstration is to show the value of global motion planning in agile production for SMEs. The project itself demonstrates this in a vision-enabled robot cell, but this cell is also supposed to serve as a demonstration of the potential of global motion planning in future human-robot applications.
Most commercial motion planners are run locally at customer premises and require a dedicated IPC for performing the calculations. In this project, we have developed a cloud-based API and a lightweight edge service, which enables motion planning capabilities running in the cloud. We have experienced how a cloud API has reduced the barrier for introducing the solution to new potential customers. It has shown to be an ideal tool for quickly giving them access to testing. In this project, we have also improved the motion planning capabilities related to bin picking. As we show in the demonstration, without any additional programming from the user, the planner enables bin picking from several bins with dynamic placement in a cluttered environment using a robot-mounted camera. We further show how our motion planner efficiently overcomes these issues with increased success rate and simplicity in cluttered and changing environments. Here we show the setup of the demonstration. We have a 6-axis robot with a 3D camera mounted on the end effector. We use a vacuum gripper with a single suction cup for the picking. The robot is serving 6 separate bins, all of them with flexible positioning. The demonstration setup shows how we can use the motion planner to automate the bin picking of several bins with only one robot arm and one 3D camera in a non-static environment. Here we see the demonstration running. Before performing the picking operation, both the bin and the pieces are detected by the vision software. The bin detection, together with the acquired point cloud, is used by the motion planner to update the environments dynamically. The pick poses are sent to the planner for evaluation, where the best collision-free pick is automatically executed. Even with the camera mounted on the end effector, challenging picks close to the environments and the bin wall are possible. For each pick post detected by the vision software, the motion planner can simultaneously evaluate several options with different orientation of the gripper. This way, without any extra programming, the motion planner increases the success rate and the efficiency of the solution.
SMEs have smaller batches and constantly changing tasks. As we have demonstrated in the demo video, motion planning simplifies many of these challenges since it enables the robot to dynamically adapt to changes in the cell. It becomes easier to program the robot for new tasks. The robot can much easier use 3D vision and in the future also collaborate with humans. In the short term, motion planning will be used as demonstrated in this demonstration in bin picking within manufacturing, and also for palletizing and depalletizing within logistics. In the medium term, motion planning will be used for pick and place in warehouse logistics. This represents a greater challenge since the robot has to pick thousands of different objects. In the longer term, motion planning will become part of human-robot applications. We would like to thank Trinity for informative workshop series productive meetings with our mentor, Dr. Assad Tirmizi at Flanders Make, and also for the financial contribution. Thank you. For more information about the module developed in the project, please visit the Trinity catalog you can access using the QR code on this slide. If you want access to the technology directly, please contact Adaptive Robotics. Do not hesitate in contacting us. You'll find my email and Øystein's email here. Thank you.